Hello students and welcome to the lecture. So students, as we all know that we are covering the Newton's laws of motion, right? This is the topic we have been discussing on since last two lectures because we have completed two parts so far. This is going to be our part 3. Okay? We are going to talk about the Newton's laws of motion part 3. Basically in this we will talk about the addition of forces. Okay, that is going to be a topic, and then we will discuss the summary of the facts and figures that we will cover in this discussion. Okay, but before starting, as usual, we have our small disclaimer over here that we are required to understand first before we proceed further. The disclaimer is like the images used in a slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this tag and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Now, let's begin first with the addition of forces. So basically, if we talk about the force, we know that the force is a vector quantity. In the previous lecture, we had talked about it like there are the two quantity, vector and the scalar. The scalar quantities are those quantities which having only magnitude, not have any particular direction. On the other hand, vector quantity is that quantity which having the magnitude and the direction as well. So force is a vector quantity. It is not possible to add two or more forces by simple algebraic rules. Okay. The resultant of two or more forces acting at a point is a single force which produce the same effect as the immanual forces together too. So like you can say, if you take any point in a reference and you say that basically there are various forces acting on this point, that statement is half true and half false. How it is possible? Because if you read this line, what is this saying? This line is saying it is not possible to add two or more forces by simple algebraic rules. And if you read this sentence, what it is saying? The resultant of two or more forces acting at a point is a single force. So like you can say, suppose if you consider this point as a point of reference, alright, and here you are experiencing two or more forces acting on this, then you can't say that there are the two forces. That forces will be the single force. Okay, like these forces will act as a single force, which producing the same effect as the immanual forces together do. So that's why I told you at any point of reference, two or more forces could not act. This is half true and half false. Okay. Now, the resultant force is thus a substitute for all the forces, and after the resultant has been determined, the immanual forces need no longer be considered. Like you can say, suppose if there are the three forces A, B, C, these three forces acting on certain point of reference. Okay. And then these forces formed ABC, the new force. Okay. So once we determine that new force or the resultant force that resulted after the combination of these three forces, that resultant force will be taken into the consideration. Okay. And the immanual forces, which means ABC, we no longer need them to consider. We will only consider the ABC. Okay. So remember this thing. Two forces are added geometrically either by the parallelogram law of addition or by the triangle law of addition. So for two forces to be added geometrically, we have the two laws: parallelogram law of addition, triangle law of addition. Okay, here we have the two. Now, if we talk about the first one, that is the parallelogram law of addition. What does it say? According to the law of parallelogram of addition, if two forces acting at a point are represented both in magnitude and direction by the two adjacent signs of a parallelogram. Okay, like you can see this in this paragraph. Sorry, in this picture, not paragraph. It's my mistake. In this picture, their resultant is represented both in magnitude and direction by the diagonal of parallelogram passing through the common sector. This. Okay. So remember, if two forces acting and their magnitude and direction represented by two adjacent sides of the parallelogram. So basically, the resultant force will be represented with the magnitude and direction by the diagonal of parallelogram passing through the common corner. So this is the first law of addition, which we called as the parallelogram law of addition. Okay. Now, if we move forward, we could say in figure, here you see two forces P and Q. Okay. Acting at angle theta at a point O are represented in the magnitude and direction by the side OA, this one, and OB of a parallelogram OACP. Alright. The resultant for R. This is the resultant force. Now you can say this is the immanual force, this is the immanual force. Okay. Q and P, immanual force. So their magnitude and direction represented by the OB for Q and OA for P in the parallelogram of OACP. Resultant force will be the R. Okay. So it is represented in the magnitude and direction by the first diagonal of OC, which is at the angle infinite with the force P, therefore OA. And this will be represented by this formula, R is equal to under root P square plus Q square plus 2PQ cos theta, and tan infinite is equal to Q sin theta by P plus Q cos theta. Okay. So this is about the parallelogram law of addition to give the direction and magnitude of the resultant force when two forces need to be added. Now, another one is the triangle law of addition. So according to the triangle law of addition, if two forces are represented both in magnitude and direction by the two sides of a triangle taken in order, the resultant is it's represented both in magnitude and direction by the third side of the triangle taken in opposite order. Okay. Thus, to add two forces PQ, the origin A of Q is kept at the terminus A of P is the resultant R, is then found by the drawing the vector from the origin O of P to the terminus C of Q as shown in the figure. So like you can say, to understand it better, now we require to read it again. Two forces represented both in magnitude and direction by two sides of a triangle taken in order. Here you can see in this picture. Then the third side of a triangle taken in the opposite order. Okay. Third side will be taken in the opposite order to show the resultant force, magnitude and direction. So if you see here, to add two forces P and Q. This is the P, this is the Q. Okay. These are the two forces, or we could call them as the immanual forces. The origin A of Q is kept at the terminus A. This one. Okay. A is the originate point from where the Q started. A of P, the resultant R, is then found by drawing the vector from the origin O of P. O is the origin of P to the terminus C. Here you can see it of Q as shown in the figure. So that will be the resultant force. Okay. So this is the this is the triangle law of addition. Previously we had talked about the parallelogram law of addition. Okay. Now, what is the moment of force, or we often called as a torque? So the turning effect of the force acting on a body about an axis is called the moment of force or torque. The turning of a body by a force depends on two factors. First, the magnitude of the force applied, and the distance of line of action of force from the axis of rotation. So now if you look at here, you are seeing this. Okay, it is a turning effect of the force. The force is applying here so that this body that you are seeing, it's getting turning, right? And basically it is called the moment of force or torque, and it is depend on the two main things. First is magnitude of the force applied, like with how much magnitude you are applying the force on the point. You can say the more the magnitude, more the force will be. Less the magnitude, less the force will be. And second is distance of line of an action of the force from the axis of rotation. Now this is the axis of rotation. From here till there, what is the distance? Okay, if the distance is less, impact will be higher. If the distance is more, impact will be lower. Okay, so these two things basically decide the moment of force or torque, or you can say the intensity of this. The moment of a force or torque is equal to the product of magnitude of the force and the perpendicular distance of the line of action of the force from the axis of rotation. Here you can say in this figure, moment of force about the point O, this one. Okay, then force inversely are distance of force from the point O is equal to F into OP. Okay, so this is. Now the moment of force is also a vector quantity. Why? Because it is having both the magnitude and direction. It does not only having the magnitude nor only having the direction. It is having the both. That's why it is often regarded as the vector quantity. Conventionally, when the turning effect on the body is anti-clockwise, the moment of force is taken positive. When the turning effect on the body is clockwise, moment of force is taken negative. So basically, in order to understand this particular thing, we have to first understand what is the clockwise direction, what is the anti-clockwise direction. In order to understand this concept, just look at the analog watch you are seeing in your room, you are seeing anywhere. Okay, do not look at the digital watch. I'm saying analog watch. Okay, so in analog watch, if you notice, you will find that basically the movement is like this. There will be a number 12 at the top, then 1, 2, 3, 4, 5, 6, okay, 7, 8, 9, 10, 11, and then this is the movement, right? This one. So this movement is happening in your watch. If you're looking at the analog watch, that's why it is known as the clockwise. Why? Because it is happening in the clock. What is the anti-clockwise? In anti-clockwise, the movement is reversal of the clock movement. The clock movement is in the leftward direction. Okay. In counterclockwise or anti-clockwise, the movement is in the opposite direction, means rightward direction. And whenever you look at your watch, at your clock, you will never find that the watch is moving like this in the rightward direction. The watch will always move in the leftward direction. So that's why leftward movement known as the clockwise turn or clockwise movement, rightward movement known as the counterclockwise or anti-clockwise movement. Okay, so now after understanding this, come to this point. So when the turning effect on the body is in the anti-clockwise or you can say rightward direction, so the moment of force is taken positive. Okay, and when the turning effect on the body is in the clockwise direction, moment of the force is taken negative. So now units of moment of force. The SI unit of force of moment of force is Newton into meter. Okay. In the CGS, the centimeter, gram, and second unit, it's dyne into centimeter. So you can say 1 Newton meter is equal to 10 power 7 dyne centimeter. Thereafter, 1 kg S equal to minus M is equal to 9.8 Newton meter, and 1 grams F minus cm centimeter is equal to 980 dyne centimeter. Now, what is the principle of movements? Okay, so basically, when a number of coplanar forces act upon a body and they tend to rotate it about an axis, The resultant moment of all the forces is obtained by summing the moment of each force algebraically. So now you can say basically there are the number of coplanar force. There is no single coplanar force. Number of coplanar force, and they are acting upon a body in a way that the body is actually tending to rotate about an axis. Okay, so when we will see the resultant movement that will obtain because of these coplanar forces acting and the tending of body to rotate on the axis, that could be obtained by summing the movement of each force in the algebraic movement. Okay, according to the principle of moments, if the algebraic sum of moments of all the forces acting on the body is 0, the body is in rotational equilibrium. So you can say you got the new term rotational equilibrium. So whenever the rotational equilibrium obtain, always remember that these coplanar force having the algebraic sum 0. Okay, if it is having some value, rotational equilibrium will be not there. If it is not having any value, rotational equilibrium will be there. Now, thus in equilibrium, the sum of anti-clockwise movement is equal to the sum of clockwise movement. Okay, that's why the impact is 0. Our physical balance or beam balance works on the principle of movements. Now, couple. What is a couple? So, two equal and opposite parallel forces not acting along the same line form a couple. Now, you can say, here you can see this. Two equal and opposite. Intensity is equal, direction is opposite, not intersecting each other, but running parallel to each other, and also not acting along the same line, so that they should not collide. They form a couple. A couple only produce rotation. It could only be balanced by equal and opposite couple. In given figure AB, is bar fixed at the point O. Here, at the end A and B, two equal and opposite forces, each of magnitude F, have been applied. Like here you can say A, here you can say B. The two forces couldn't produce the translation motion as their resultant sum is 0. Okay, but they have the turning effect in the same direction and therefore forming a couple which rotates the bar in anti-clockwise about the point O. Moment of force F at the end A is equal to F into OA. Moment of force F at the B is equal to F into OB. Total moment of couple is equal to F into OA plus F into OB is equal to F into OA plus OB is equal to F into T. Thus, the moment of couple is equal to the product of either force and perpendicular distance between the line of action of both the forces. If the couple having the tendency to rotate the body in anti-clockwise direction, so as we just you can say learned about here, whenever the rotation will be anti-clockwise, always the impact or movement will be positive. And if it is having the rotation clockwise, that will be negative. So same happen here because the couple forces are there to generate the rotation. So if the couple forces having the tendency to rotate a body in the anti-clockwise direction, that movement will be positive, and if it is in the clockwise direction, that movement will be negative. That's it. So when we talk about the units of couple, so SI unit of couple is the Newton meter Nm, and in the CGS, the centimeter gram and second system, it is the dyne centimeter. If we take the example of couple action, so rotation of a body is always due to a couple because the couple forces are equal and opposite forces and also not on the same plane. So the collision effect is 0. That's why they rotates the body by the virtue of their forces. When we open a door, the rotation of the door is produced by a couple consisting of the force which V exist and an equal and opposite direct force due to the reaction at the hinge. Alright. Turning off a water tap, tightening the cap of an ink pot, turning a key in a lock, winding a clock or a watch with the key, steering of motor car, driving the pedal of bicycle, etc. These all are the example of couple action. If we talk about machines, so what is machine? So basically, a machine is a device by which we could either overcome a large resistive force at same point by applying a small force at a convenient point and in desired direction, or by which we could obtain a gain in speed. Machines are useful to us in the following four ways: to lift a heavy load by applying a less effort, therefore as a force multiplier. For example, when you put a jack below the car lifts up. The car is heavy in comparison with your pulling up capacity. The bar is used to lift a heavy stone. To change the point of application of the effort at a convenient point, for example, the wheel of a cycle is rotated by applying the force on pedal with the help of chain. To change the direction of effect in a convenient direction, for example, a single fixed pulley is used to lift a bucket full of water from the well so that effort may be applied in the downward direction instead of applying it upwards, because that will help you to change the direction of the force. To obtain gain in speed, for example, a gear arrangement is used in automobiles. Principle of a machine: the resistive force to be overcome by a machine is called the load, and the force applied on the machine to overcome the load is called the effort. A machine does not work by itself. When energy is supplied to it or work is done on it, it does some useful work. The energy supplied to machine or the work done on the machine is called the input, and the useful energy obtained from the machine or the useful work done by the machine is called the output. Okay. The point at which energy is supplied to a machine by applying the effort is called the effort point. The point where it's obtained by overcoming the load called the load point. Input energy is equal to effort into displacement of point of application of effort. Output energy, load into displacement of point of application of load for idle machine. Input energy is always equals to the output energy. So the much input you put in a machine, the much output you gain from the machine. But in actual practice, no machine is idle, and therefore the output energy from a machine is always less than the input energy. So now it's part for summary. We discussed the concept of force, torque, and machine. Force is a vector quantity and couldn't be added using simple algebraic rules. Resultant force of multiple forces could be found using the parallelogram or triangle law of addition. Torque, we have talked about. Principle of movements, we have talked about. Couple consist of two equal and opposite forces, that we have talked about. Movement of a couple, we have talked about. Machines, we have talked about. The load resistive force, we have talked about. The input and output energy, we have talked about. With this, we have finished this lecture. It is requested to all of you, kindly revise the facts and figures that all we have discussed in this lecture and keep yourself ready for the next lecture. With this note, let's end this lecture and thank you.